The eighth question that we have is again an interesting question. We have been given box product of these three vectors. You have to prove that box product of these three vectors is equal to box of ABC whole square, and that is also equal to the value of this determinant. So let us solve the first part first. We have A cross B, B cross C and C cross A. We know that box of ABC is equal to A dot B cross C. So let us solve for this. A cross B dot B cross C cross A. We can write this as like this. Now this can be written as A cross B dot, let this be equal to D. Whenever you have something cross something and the second term, the second vector is a bit lengthy or something, you substitute that as D. So let this be equal to D vector. Therefore this becomes B cross C cross D. Therefore this becomes A cross B dot D dot B into C vector minus D dot C into B vector. Now let us again plug in the value of D. D was C cross A. Therefore we get C cross A dot B into C vector minus C cross A dot C into B vector. Now we know that C cross A vector is perpendicular to both C vector and A vector. So this vector which is perpendicular to C vector, when taken dot product with C, will give us 0. Therefore the second term becomes equal to 0. And on the left we have C cross A dot B. Now C cross A dot B can be written as C dot A cross B, and that is equal to box of CAB. Therefore this becomes box of CAB. Now we know that if we maintain the same cyclic order, that is ABC or BCA or CAB, the box product remains the same. Therefore this can be written as box of ABC. Now this term becomes equal to 0, therefore this can be removed. Therefore we have A cross B dot box of ABC times C vector. Now since this is a scalar, this can be taken out. Therefore this becomes equal to box of ABC into A cross B dot C vector. This is again box of ABC. Therefore this becomes equal to box of ABC whole square. So we have proved the first part. For the second part, let us assume A vector is equal to A1 I cap plus A2 j cap plus A3 k cap, and similarly we assume B vector and C vector to be B1, B2, B3 and C1, C2, C3. Now let us solve it. Let us write the value of determinant, the determinant formed by box of ABC. We know that the box of value of box ABC can also be written as A1, A2, A3, B1, B2, B3 and C1, C2, C3. The value of this determinant will be equal to the value of box of ABC. Now we need to prove that box of ABC whole square is equal to this quantity. So the value of this determinant multiplied by itself should give us this determinant. So let us write that A1, A2, A3, B1, B2, B3, this is delta square is equal to A1, A2, A3, B1, B2, B3, C1, C2, C3 multiplied by the same determinant. Now if we take the transpose of the determinant, the value of the determinant does not change. Therefore we can also write this as A1, A2, A3, B1, B2, B3 and C1, C2, C3. Now we know that by the rule of matrix multiplication or determinant multiplication, we can write that the final resultant determinant will be the first row first column element will be found by multiplying the first row over here by the first column, that is summation A1 square, that is A1 square plus A2 A1 square plus A2 square plus A3 square the term over here becomes, this is first row, second column. Therefore, this becomes first row into second column, that is A1 B1 plus A2 B2 plus A3 B3. That is summation A1 B1. We can write this as summation A1 B1. Similarly, first row, third column can be written as A1 C1 plus A2 C2 plus A3 C3. That is summation A1 C1. Similarly, we will get this one as summation B1 square, this one as summation C1 square. This we will get as summation B1 A1. This we will get as summation C1 A1. This is second row, third column. Therefore, second row multiplied by third column will give us summation B1 C1, and this will be equal to summation C1 B1. Therefore, this is the final determinant which we get after multiplication. Now, as we can see, this can be clearly also written as A dot A dot B, this is A dot C, this is B dot A, B dot B, B dot C, and this is the third row is C dot A, C dot B, C dot C. Therefore, hence we have proved our final result. You can try to remember this part at least, because this part can be used in different questions to solve the questions faster.